Welcome to qnawire.
Welcome to a new problem. This is an elevator problem. So it starts on the ground floor, and the elevator is going to be lifted up a distance of uh, 20 meters. That's 5 floors. The mass of the elevator happens to be 600 kilograms, and there are going to be people inside the elevator. We don't know how many. So let's just call them X. X stands for the number of people um, inside the elevator. And that's the number we want to find. The information given is that it's being powered, the elevator is being powered. So by a motor that has horsepower. So horsepower is a different unit of power. If we have large power, so this is 40 horsepower. And so the question is how many people, how many passengers are going to be inside the elevator if each one weighs or if each one not weighs but each one has a mass. Remember, weight and mass are different. Weight is a force, mass is a weight is a force vector, mass is a scalar. So the mass of each passenger, which I'm going to call mp, is 65 kilograms. If the elevator has to go all the way up, it means it has to oppose the weight of the people, all the people inside the elevator. And so it has to oppose the mass of the elevator and also the mass of the people. We have X people, each one of them is MP. So the total weight being opposed is equivalent to this one. If the elevator gains height up until 20 meters, then you can recall that the potential energy at any specific height is mgh. And so the total potential energy gained by the elevator together with the people inside is me x mp. Remember, me stands for the mass of the elevator. This one is the mass of the elevator. And mv stands, or rather mp stands for the mass of each one of the passengers, and then times h, which happens to be the height that the elevator has to go all the way up. We want to know what energy is expended in moving the people from the ground level 5 floors up until a height of 20 meters. Remember, power is energy over time. So the energy has to be the power times the time. And we can use that as a formula. So the potential energy, or the energy expended to move all these people up, happens to be PT, or the power times the time, which equals to ME plus X MP times H. The time taken to move all the passengers all the way up happens to be 16 seconds. And we want to know how many passengers are moved all the way up. I forgot the G, so this G is part of this equation. It's going to be right here. And so I want to solve for X. Divide both sides by GH. And then I have PT over GH equals to ME plus XMP. Subtract the mass of the elevator on both sides, and then we end up with XMP being equal to PT of GH minus the mass of the elevator. And so to solve for the number of passengers, we take the X, PT, we'll divide everything by the mass of each passenger. So the mass of each passenger, and that gives us PT over mpgh minus me over mp. So this is just a different way of approaching the problem, where you deal with the variables up until the end of the problem. So you keep the variables up until the end of the problem, and then you solve it. You solve it after that. So if I punch in the numbers, and I can do that on the next page. So we have x, which is the number of passengers, equals to pt over pt over mg. I have to go back and forth. mpgh mpgh minus the mass of the elevator over the mass of the passengers. So the power, remember, it's horsepower, so we have to change that to a different set of units. So we have 40 horsepower times 746 watts over 1 horsepower, and then times the time, which is 16 seconds, all over the mass of each passenger, which is 65 kilograms, times 9.8 meters per second squared, times the height, which is 20 meters or 20.0 meters, minus the mass of the elevator, which, if you can recall, happened to be 600 kilograms, over the mass of each passenger, which is 65 kilograms. So if you simplify this problem, I'm going to use my calculator. So I have 40 times 746, okay, and then times 16, and then divide by 65 times 9.8 times 20, and then I have to subtract 600 divided by 65, and this gives me 28.24. So approximately 28 passengers inside the elevator. Okay, 28 passengers inside the elevator. So one of the strategies is to just keep the variables up until the end. The idea is that there's energy that's going to be expended in moving the elevator and all the passengers up until a height of 20 meters. And we need to find that energy based on this formula right here. Energy equals to power times time. And so we make that equal to the gain in potential energy for the passenger and the elevator. The basic potential energy formula is mgh, but then the mass involves the mass of the elevator, and then the total mass of all the passengers I have to multiply by x, because each passenger is 65 kilograms. So then once we make those two equations equal, we just solve for x. That's our goal. So we're using algebra, and then once you get a clean formula for x, you can plug in the numbers, and you want to be very careful with punching in the numbers, as you can see in the next page, and you get 28 passengers. So hopefully you enjoyed the problem. Feel free to send any questions or comments my way, and have a wonderful day. Okay, bye.